Hello, I'm Kieran Callahan, and in this video from the ETTA, we're going to look at how to assemble the GENIE E18 motorboard, similar to the one shown here, which was given out at the National Conference there 2 weeks ago. So if you're putting this together, you're either a student or a teacher who wishes to use the GENIE E18 motorboard in some of your projects. This is an excellent way of adding control to motors that you're going to use inside in your projects. Now, if you're a bit daunted by all the components that are given to you in the pack, don't worry, it's pretty straightforward. Everything is labelled out very well, and it takes around about 30 to 40 minutes to assemble the board and solder all the components in place. To begin, we're going to go through what tools we need to use for putting our board together. So the tools you need to assemble the board are pretty straightforward. You'll need a long nose pliers, you will need snips, you'll need some solder, and you'll need a soldering iron. And now will be a good time to plug in the soldering iron to allow it to heat up before we begin to assemble the board. So we're looking here at the bag of the GENIE E18 motorboard as you would have received it. To look at the components that are inside, we'll just open up and have a little look at what we've got here. If we look at what we've been given in the bag here, first of all, we have the battery holder. This battery holder will put 4 AA batteries together to give us a total of 6 volts going to our motorboard. I'm just going to lift that over out of my way. So in this pink bag, this is statically sealed to prevent damage to the 2 chips that are inside it. The 2 chips here are the GENIE E18 control chip and also the L293D driver chip, which will allow the GENIE board to control the motors that you've put in your project. So I'm just going to use my scissors to open this guy up, and we'll have a little look at what's inside. Inside here we have 2 DIL sockets which will allow us to mount the 2 chips onto the board themselves. If I look at these 2 chips, I can see that the bigger chip of the 2 is the GENIE E18 control chip, and the other chip that I'm given there is the L293D driver chip, which is the chip that will allow the GENIE board to control the motors attached to our project. Some of the other components that are given to us inside in the pack, we have a little bag full of resistors and a diode. There we are there. We look at those guys as we're assembling the board itself. Some of the other components that were given in the board here, we have the battery terminal connector. We have some terminals for connecting our board to our motors. We have a download socket which looks kind of like a headphone socket. That's going to allow the computer to connect to the GENIE board to tell it what to do. We have some capacitors, an LED and a reset switch. And I'm going to lay some of these components out up here at the top of the board, and I can get to them as I need them. And the main part of the GENIE board is the printed circuit board itself. This is one of them here, and on the side I'm looking at, I can see that all the components are labelled on the printed circuit board of where they individually go and which order they should be connected in. And if I look at the back of the board here, I can see all the different circuits that the components will be linked up through each other to control the motors connected to our board. So we're going to zoom in a little bit closer and have a look at the board itself. So looking at our printed circuit board, as we've just said, all the different components are labelled where each part goes. So it's pretty foolproof in putting together. So we're just going to start off step by step. To begin, we're going to put the biggest components on first. We're going to look at the DIL sockets, which will allow the 2 chips, the GENIE E18 chip and the driver chip, to be mounted onto the board. So I'm going to go to the package that has the driver sockets on it, and I'm going to take out the little mounting plate, the DIL socket, which will match up with my GENIE chip. And I'm going to mount that onto the board. In mounting this on, there is a certain order it has to go on in. If I look at the side of the socket, one side of it is flat and the other side has a slight semicircular groove taken out of it. If I look at the GENIE board itself, I can see that one side is flat on the diagram and one side has a semicircular groove taken out of it. And that should correlate that when I take the DIL socket, it should mount in there, push fit with the 2 semicircular grooves on the same side. So I'm going to put that guy on, and I'm going to do the same with the 293 DIL holder. There's a semicircular groove on one side of it, and I'm going to ensure that that matches up with the semicircular groove on the other side of the printed circuit board. So now I'm going to take the board and I'm going to flick it over, and I'm going to solder in these two connectors. Now some people may prefer to install all the components and solder them at the one time. Personally, I prefer to solder them on one piece at a time. I'm going to begin by soldering on the two biggest components, which are those sockets. So I have my soldering iron heated here, and I'm going to hold it just over the leg and pin. And remember, the solder will always flow to where the heat is. So rather than heating the leg and allowing the solder to flow down, we want to try and encourage the solder to flow up the leg of the component itself. So we'll just hold them there. And we have to do this for each of the components. So I find that about 5-6 seconds is enough to hold to get a good soldered joint. So now that we have the DIL socket soldered in place, we're now going to look at mounting on the jumper pins which will allow the motors to connect to the board. So we're going to look at inserting these guys in this location as shown, and the three of these guys sit in place just there. Now these pins are very prone to falling out and wobbling around as you try to solder them in place. So to try and limit that, I'm going to put a little bit of insulating tape across this guy, and I'm just going to ensure that he's pushed in fully by squeezing down on that little bit of tape right there. And now that should ensure that the pins are sticking out a good distance for me to solder them into place. So again, as in with the DIL sockets, the objective is to get the solder to flow up the leg of the component and give us a good connection. So there I have those three legs soldered into position, and I'm just going to remove the little bit of tape that I had holding them in place. So looking at the other big components of the board, if I take the upload socket, which looks like a headphone socket that you would have on your MP3 player, and I'm going to mount that in place on the board as shown. That guy push fits in there, and I'll ensure that he's in nice and snug to the base of the board. There's one single pin up at the front, and I have 4 more pins down at the base here. So we'll just put a little drop of solder on each of the pins. So now that we've soldered in the upload socket into place, we're going to carry on with more of the components on the board. So I'm going to look at the small reset button, which is mounted in here to restart any program you've uploaded into the board. This guy has slightly twisted legs, and he will insert into the board as shown. So moving on to the next big components of the board, we're looking at the voltage regulator, which is this little guy here. It looks very like a transistor, and it's going to go in place as indicated on the board here. So I'm just going to put each of the 3 legs in there, and I'm going to push them on down so they stick out the back. As you insert this, it's important to note that the flat side of the component should match the flat side of the diagram closest to the driver chip. And I'm just going to push them on down here fully. So the next component I'm going to insert on the board is the green status LED. That indicates to us that the board is functioning correctly. So the green LED, as in all other LEDs, is polarized. It has a positive leg and a negative leg, and it must be inserted in the correct order for it to work. Well, thankfully everything on the GENIE board is very clearly labelled, and as we can see, the LED shows us the flat side, and that should correspond to the flat side of our LED. If you're unsure which side is the flat side of the LED, by looking at the legs, we can see that one leg is slightly shorter than the other one. That is the neutral leg, and that must be inserted closest to the flat side as indicated on the diagram on the board. And if I just pull this guy on down fully, we should see that the flat side of the LED here is now matching up with the flat side of the diagram. And as before, I'm going to turn the component over and I'm going to solder him into place. So the last big component I have to insert on the GENIE control board is the electrolytic capacitor. The electrolytic capacitor is this little guy here. The electrolytic capacitor is polarized. That means he must be inserted in a correct manner. One leg is a neutral and one leg is a positive. If I look at this, just like the LED, the shorter leg is the neutral leg. It's also indicated by the white stripe on the side of the electrolytic capacitor. The longer leg, which has no stripe on the body of the capacitor, is the positive. And if I look down here at the diagram, I can see that where the capacitor goes, I have a positive beside where the long leg should be inserted. So I'm just going to push that guy in, push the neutral leg in through, and this guy I'm going to gently push him down home so he fits nice and snug on the board itself. And as with all the components before, I'm going to use my snips to take off any excess leg that is left on the components, because after all I want this board to be nice and neat and tidy. So now that I've got the electrolytic capacitor soldered into place, I can now insert the other capacitors that were given to me. In the pack I'm given 4 little capacitors like that. They are inserted in the board here, here, here and here. They're 100 nanofarad capacitors and they're labelled very, very clearly on the board. Now these guys are non-polarized, which means that I can insert them in any manner that I want to. I'm going to insert the first guy in here and push him down fully. I'm going to insert the second guy where he should be in here. I'm going to insert the third one just to the right hand side of the driver chip, and I'm going to insert the last one just up above that here. I'm going to push them down so they're a nice snug fit and they're very close to the base of the board. And carefully I'm going to turn the board over and I'll put them sitting upside down there, and I will solder each of these guys into place. Now just a tip for you, if you want to hold them in place and you find your pieces are falling out, if you take one leg off it, pull it up so you know it's snug to the base of the board and bend that leg over as I've just done. That will help to keep the component in place until you have it soldered. So I'm now going to solder in the bottom leg of that component. And once I have one leg soldered, I can turn the other leg I had bent down to hold the component in place and put another little drop of solder just beside that. And I'll now solder in the other 3 capacitors in place. There we go, and as before I'm going to clip off any excess legs using my snips. So now that we have the capacitor soldered into place, the next component we're going to look at is the diode. The diode is in the bag with the resistors, and he's easily identifiable because it has a black body, and if you look close you will see that there is a silver band on one side of the body. If we look at the PCB for the GENIE board itself, we can see that we have a spot that's labelled for the diode. It's just up here, just above the voltage regulator. So to put that guy into place, I'm going to take him and using my long nose pliers, I'm going to bend over one leg of him there, roughly 90 degrees, and I'm now going to compare the length of that So if I sit this guy across the GENIE board now, I can tell roughly what length he should be to sit in comfortably when I put the bend on the opposite side of the body. When inserting the diode, it's very, very important that the silver band on the body of the diode matches the band as indicated on the printed circuit board for the GENIE. So the silver band should be on the left hand side as we look at the board, and when we push this guy down fully, that should match up with the diagram as shown. Now, like the last component that we inserted, we're going to hold him in place and we're going to bend one leg over to hold that guy in a snug position while we turn the board upside down to solder it into place. Put another dab of solder to hold the component in place. I can snip off the excess terminal legs to give me a nice smooth finish on the board. Now, moving on to look at some of the resistors. The resistors that I'm going to start off with are the 0 ohm resistors. There should be 2 of these guys, and they are identifiable because on the body of the 2 resistors is one black band. These 2 guys are marked LK on the printed circuit board for the GENIE. So I'm just going to pull off the paper covering on the ends of these guys, and just like the diode, I'm going to put a 90-degree bend on one side of them so that it will fit in, and I will check on the GENIE board that he's in the right place, run a bit there, and I'll put another bend in just like that. Now I'll check him for length. He should fit in nice and neatly on the GENIE board just there. So one of my 0 ohm resistors fits into that slot there, labelled LK on the GENIE board. Now the other 0 ohm resistor is mounted just above the driver chip. It's also Now the other 0 ohm resistor we have to insert on the board is just above the driver chip. It's labelled LK on the board, and it goes in there just like that. So now that I've got the 0 ohm resistors in place, the next components I'm going to insert on the board are the 330 ohm resistors. There should be 4 of them on a strip like that, and they're identifiable by looking at the side of the resistor, and we should have orange, orange, brown and gold indicated on the side of them. Now the resistors are also non-polarized. They can be inserted in any manner, but we'll try and insert them in the same direction just for continuity and to keep the board looking nice and neat. And if I look at the board itself, I can see that I have space for 1, 2, 3, 4 resistors to go on it, and they're all labelled 330. So I'm just going to insert these guys and solder them into place. So my GENIE board is starting to take shape. There's very few components left to go in. The next component I'm going to insert is the 4.7 kilo ohm resistor. It's labelled yellow, violet, red and gold. There is one of these in your pack. It's yellow, violet, red and gold. This is the 4.7 kilo ohm resistor, and that goes into the board at the space shown here, just to the left of the reset button. Okay, and I will insert him into the area shown. So the next component that we'll insert on the board is the 10k ohm resistor. Now, it's coloured brown, black, orange and gold, and there should be 5 of those guys, and they are all mounted on a little band like so. And if we check the colouring on them, we should have brown, black, orange and gold. And those guys, if we look to the board itself, where we see the slots with the 10k, there should be 5 of them. So we have on the left hand side of the board 1, 2, 3, and just to the right hand side of them 4 and 5. So we'll go ahead and insert all 5 of these 10k ohm resistors. So we only have a couple of components left to put on our board now. The first of which is the 22 kilo ohm resistor. So you're looking for one of the 2 resistors which is remaining, and it's coloured red, red, orange, gold. And this is the guy we're looking for here. And we can see the colourings on him are red, red, orange and gold. So we'll just insert him in the board and solder him into place. And the place where this guy goes is the 22k resistor, just here. And now the second last component to be mounted on the board is the 100 kilo ohm resistor. It's the last resistor you should have there, and it's coloured brown, black, yellow and gold. And if we check the colourings, brown, black, yellow and gold. And we'll insert him just beside the last resistor we inserted, which is at the back of the upload socket. So the last component we have to insert on our board is the piezo sounder, this little guy here. He's mounted in place here, and there are 2 spots we can wire him in. We can wire him into the 2 slots underneath the sounder, or we can also wire them into the spot labelled P3. And if we turn the board over and we have a little look at the back, we can see that the 2 points are on the same line. Now we can also see that this is labelled plus. So this point here, as I turn the board over, the point on the left or on the base of the board must have the red wire inserted there. That is the positive line, and it must have the red wire inserted on it. And I'm going to strip back a little bit of wire of this and mount him into the board. And I'm going to put a tiny drop of solder onto the ends of those wires. Now I'm just going to put a tiny drop of solder onto the ends of those wires to stop them fraying. So now, having put a small bit of solder on the end of the wires to prevent them fraying, I'm now going to insert them into the slot labelled P3 on the board. There we go. So there we have the sounder soldered into place, and just to hold them in position, I'm going to put a tiny bit of blue tack in the centre of the board, and that will just hold my piece in position. So now all the components are soldered into place on the board, and the board is almost ready to work. Just before I insert the chips and power up the board, I need to connect the PP3 battery connector, which was given to me in the kit, this little guy here. So I'm going to solder him into place, and I've just twisted the ends of the wires together to keep it nice and tidy. I'm going to solder these 2 in place in the components indicated. I'm just going to solder this into place at the points indicated at the top of the board. So I have the 0 volt where the black wire should go, and I have the plus voltage where the red wire should go. And I will now solder these guys into place. So now that the board is fully assembled and all the components are in place, I will now take the GENIE driver chip and the motor driver chip and insert the two of these into place. Now when you insert these, it's very important that we check the side of the chips. On the top corner of the GENIE chip, we can see that there's a small semicircle taken out of the top of the chip. And if you recall back to when we were inserting the DIL socket for this, we knew that that was on the left hand side of the GENIE board as we looked at it. So it's very important that it matches that orientation. So I'm just going to push fit this guy into his socket. There we go. Similarly, with the driver chip, I will ensure that the semicircular cutout is on the left hand side and matches up to the one on the DIL socket for it. And we'll just check again that they're nice and snugly fit. And there we have one fully assembled GENIE board. So just to check my GENIE board, if I connect my power source to the PP3 battery clip that I've just connected, my green status LED has flashed to indicate that it's receiving power. So just to check that that's working okay, if I depress the reset button, I should get a signal flash. And there I know my GENIE board is working okay. So that's our GENIE board assembled, and that's the big work of it done, and now we're ready to start using our GENIE board to control the motors in our project. So be sure to tune in for the next video and we'll see about assigning the inputs and outputs on the GENIE board and making the motors start to work. So thank you very much for watching, and be sure to check out further resources on the GENIE board at www.genieonline.com and on www.t4.ie. For the ETTA, I've been Kieran Callahan. Thank you very much for watching.